and I think the winner should get a DX Commander Classic. There we are. So you can enter this and win. Hey, very good day everybody. My name's Callum from DX Commander. Now then, I have got a challenge for you. What I want you to do, and there'll be a winner in this, okay, so you might win something, and I'll tell you what you'll win at the end of this. I'm after at least 10 people to try this out. I want you to build me an emergency, well, build yourself, an emergency 20-metre vertical. Can be elevated or ground mounted, doesn't really matter, but you're not allowed to use any amateur radio gear apart from the coax, not even the plug, okay? So, how do I anticipate this working, by the way? It's ideally got to be out of scrap, okay?
Okay, well, challenge accepted. So, what do we want? We want an emergency antenna. No. Okay, which wants to be 20 metres. Well, it wants to be on the 20-metre band. Okay, and he's talking about a quarter wave. Okay, so if we're going to make a quarter wave, and if I'm going to make a vertical because I've got absolutely nothing to hang off. So we've got no trees. I don't even have a chimney pot on the house. I could string something over the roof, but it all gets a bit Heath Robinson. So I reckon we'll just do a straight vertical. And I've got nothing to hang off, so this is where the challenge is. So we'll have a vertical element here, and we basically will have some radials coming off this, like so. So to work out the length, this is what every schoolboy wannabe ham radio operator should know, is how to work out this. Well, we can work it out because we know we need to work out the wavelength of 20 meters, which is it's basically the speed of light, which is 300 million meters per second, divided by the frequency that we want. So the 20 meter band runs between 14 megahertz to 14.350. Well, it does here in the UK anyway. So if we want the centre of that band, that's going to be 14.175 megahertz. So we calculate that, if I can get my trusty calculator to work. Here we go. So we can basically say, so it's 14.175 million hertz. That's basically what we're saying. So we can drop the millions off, and we can just go 300 divided by 14.175. 1.75. Okay, and that gives us 21.64 or thereabouts. So divided by 14.175. So, and if we want a quarter wave of that, so we just divide it by 4. So divide by 4 equals, so our wavelength for a quarter wave, we'll just do a lambda, equals 5.291 according to this. Okay, so to feed the antenna, we're going to need coax, so a feeder. Now there's a velocity factor in here because the radio waves don't travel at the speed of light. I'm sure they'd like to, but they don't. apparently, if I can get this thing to work properly. So what we do, we multiply this by a velocity factor, and I don't know the coax I've got, but it's normally about sort of, 0.95. So we get times 0.95. So that gives us 5.026. Now that's probably not going to be right, never is, because I think it's to do with the length of the feeder. There's also other effects that are taking place, which I don't know. I'm not sure what they are. So, but that's 5.026 meters is what we want for our radiating element. And then these radials, well, I'm just going to make them the same, Put 4 at 5 meters. So, so, and then just run them off. Now, the challenge for me is obviously we've got to make this out of scrap. We've got to make this, or not necessarily out of scrap, but things that are not ham radio. So, we'll see what we've got lying around the house and see what we can do. But I've got nothing to tie on to, so I've got no trees. I've got nothing. I've got some electrical pylons, but I don't think that should be such a good idea. So, yeah, I've got to go away and figure out a way to do this. Okay, so he did say that, as part of this, you can't use any amateur radio stuff. I mean, you can use coax, and you're obviously going to have a plug on the end of for the transceiver to plug into the transmitter. It's just obviously where it connects to the antenna. That's where we don't have a plug. So I'm sure that's what he meant. So I've been thinking, because we haven't got anything we can tie on to elevate, and I don't have a pole, because you could use a fishing rod or something, so we decided that a tape measure would be good. I think that's a bloody good idea, because that'll go out. This is 10 meters. This will go out to, you can pull out 5 meters or whatnot, and we can get it to a height. But how's it going to stay up? So if I hold it like this, if the camera, my trusty camera person, camera woman, and this, obviously we've got this problem, but they're very strong in that way. So obviously, it goes, but it is quite rigid. Now, it's made of sprung steel, which is obviously conductive, and I reckon if we pulled this out to 5 meters, now there's, there's the inside here, there's another 5 meters coiled up. Now, I'm not quite sure what kind of effect that's going to have, because as the effect, you could actually make this half wave. But I'm not sure, and I'm not sure of the transmission effect either, because this obviously the shape of this. But there's always, if you're unsure about something, try it. That's the thing. That's my motto anyway. So I reckon what we do, we get 2 of these and fix them in the centre, and then one side will support the other and sort of make it rigid. I think it'll work. I mean, I don't know. And once you've got it pulled out, we can actually pull a bit of paint off. Sort of here, I've got a little Dremel or something, and I can just expose a bit of the metal there, and then I can actually tag onto it with probably a crocodile clip or something. And then we'll stick some RF up here. Obviously, we've got to do the ground plate, but the other things I'm going to be using, this is for now, obviously we've got tape. it's going to need guys. So this is just, it's, I can't remember what material it is. It's a poly something or other. You know, it's a man-made fibre. It's not conductive. I suppose it's not too happy when it gets wet though. Maybe, I don't know, we'll have to look at that for guys. We've got some little bungees for the guys because I want to try and keep them under a slight bit of tension. Doesn't need to be a lot, but it needs to have a bit of go in it, and that's because I'm concerned about the rigidity of this. For radials, I've got this garden wire. This is what we use around the garden for a variety of things, you know, so I can use that. And then for the guys, I've got these, again, these are gardening. You know, these are for gardening. And you can just, you know, it just makes a, you know, it'll be good to tie the guys down. The idea if I can tie, I'll have to sort of probably drill it or something to get the guys to fit, but you know, that's the idea. More tape and double-sided, some double-sided sticky foam pad sort of stuff. I'm going to try and glue I was going to use it to connect the two insides. Now, if I want it so it can pack away, that's going to then be a bit of a problem, but I can actually probably get some little plastic clamps that clamp it in the end, but I'm not going to bother until I can test it. So if we cut strips of this and I stick another tape measure to it, it should, you know, basically give us, it should be quite rigid. Well, one would hope so. So I've got no idea. I'm concerned about what's going on in here, but you know, with the coil, but it may work. It might like that, you know. I can actually, it's going to have an inductive property of some sort with the RF. Yeah, and I'll have two, and if I've tacked on, there may be some inversion, sort of radiation inversion happening. I don't know. Let's get it going. We'll have a look at it. Okay, so let's see what we can put together. Okay, so we're clogging up the lounge, and we've got a tape measure laid out. Now you can see we've actually put the double-sided sticky pad tapey stuff, whatever it's called, on there, and they go all the way to here. So this is 5 meters, and this is the end of the tape. So what we're going to do is we'll put the other tape on the back to back on this, and obviously this 3M tape will hold it, and the hope is that it will be rigid enough to stand on its own. We'll have some little light guy ropes or strings, but I'm hoping it will be, you know, it'll be okay on its own. So obviously I've got the two taped together there. I'm just using that background to stop it flipping over. So anyway, come on, you've got to get the rest of this tape off. We haven't got all day.
I'm not your slave.
I've got my trusty assistant here, which is, we've actually stuck it's Scotch, I think it's Scotch, it's 3M, and it's that double-sided sticky foam. It's designed for outdoor use, and my assistant is kindly, patiently removing the little plastic covering that's on there. Okay, so we've fixed all the adhesive to the, obviously the measuring tape, and this is on the domed part of the tape. We've removed all the little red tape, which is the, you know, to stop it sticking. So it's ready for the other tape to go on top, which I'm a bit concerned about because this stuff's pretty strong. So the problem is We've got to pull the other tape and make sure it doesn't stick, and then we'll marry them together.
Marriage?
So it'd be like a marriage, yeah. So,
Alright.
okay, I'm holding this wire. It's just for this mic. Okay, so you could have told me. Collar's all bloody hanging out. Right, so, yeah, I reckon what we'll do, we'll use some of these bad boys. As a separator. So if I lay them down. Okay?
Alright.
Okay, so we've got it laid out, and I've got these little guys which are very light, which we're going to tie on at about 1.5 meters. So what we'll do is get some tape. Those nasty ends off that. Making it worse. Okay, right, so if we put a little length in there, bring the tape over, tape that in there. Ooh, tied it around, and we can bring this down across. In there. Ooh, it's sticking. That's what it's supposed to do, I guess. I'm struggling with this. I think that'll get it, you know. It's only a test, so we'll have to find a... Oh, that's not good, is it? We could tie a knot here, couldn't we? What do you think? Right. Okay, let's put that in there. Tie it again. Oh, that's got it. Yeah. Okay, so we're going to take off the paint or whatever material it is. I'm presuming this will come off okay. So we can connect a connector block. So that's 5 meters there. I'll zoom in on that bit there. That works good, doesn't it? Yeah. Okay. We can probably take this one off this side as well. Okay, so for the ground plane, we've got these little copper. These are labels for plants. So you just get them from a gardening shop. They cost very little. They're made of copper. It's quite thin, but you know, it's perfect for making a connection. There's a little hole in the top for lining them up. So what we've done, we've soldered 8 of them together for radials. You know, something to attach the radials to. My trusty companion here. Hello.
Hello.
She is just
Amazing.
amazing and soldering them together. So I'll let you carry on. Go on. That's it. Look at that dab iron. Dab with an iron.
Oh, wrong one.
Okay, so now we're soldering these little stabs of wire. This is old speaker wire. So we're soldering these onto the ends. Then ultimately we're going to put a connector block on the end. If it'll focus, of each one of those wires, so we can connect the radials, and then we've just got to figure out a way of connecting this to the coax, the outer sheath on the coax. Okay, so now we've got our coaxial feeder, PL259. It's not RG58, it's 58, I can't remember what it is, but it's a little less lossy, but it's perfect for HF. And on the connection side, this is obviously connects to the antenna. We've got 2 crocodile clips here, which is actually connected to the centre of the coax. Obviously, you know, the bit that's covered by the dielectric, and that is connected to the braid, and that's it. Okay, so we've got it put up. This, yeah, it's a bit tricky to get it onto the garden table, but there it is. And obviously you can see the guys coming down. If we take a closer look, so to insulate it, I've just used this soap box made of plastic. Now, the end of the feed line, the feeder or the coax, got 2 crocodile clips on there, and they're clipping onto, as you can see, that section there. Now I've been careful to keep those the same length, and coming off we've got the outer braid or the ground, and that's going to a ground plane that we've made, and then we've got 4 radials coming off, which are approximately 5 meters long. Well, I know they're exactly 5 meters because of the old speaker wire off our hi-fi system. We've now got a system that runs, it's just Wi-Fi, so there's no, they just literally plug in the wall, and we don't need the speaker wire anymore, so that's perfect. And they are exactly 5 meters. Well, it's slightly shorter because I've pinched some to do these, so they're literally just soldered on. And I could have done this without soldering. We've just got a pair of tin snips, and cut a slice into there, bent it up, and put it into a connector block, and then tie the radial on that way. And we've got a little clamp there, which is basically just, it's a strain relief for the cable. So if we pull it, now what I've done, I don't know if you can see that, I've just put in some hot melt glue. I just run a seam up there, which seems to be a lot more rigid. Now I'm not sure how well this is going to go in the rain, but in the wind. But this is an experiment, so I just want to see what we get. Now, obviously the main concerns I've got is we've got two pieces here, you know, so that they're electrically separated. We're joining them together at the bottom. The R joined at the top, and then we've got these two, well, essentially coils with probably a little over 5 meters coiled up on each. And I think they're just going to be wasteful. I think what's going to happen is it's going to see I don't know, maybe an inductive or a capacitive load at the bottom, and it will be, that may load it. But this is, this is first attempt. So the thing is, we need to put it on a antenna analyzer. Really, I'm a bit reluctant to put a radio on it. I haven't got an analyzer, an antenna analyzer, but I do have, obviously, because I do radio engineering and such like, I do have a spectrum analyzer, so we can basically get an idea how it's performing. These little bungees are at the bottom here. There's very little weight on the thing, on those little stakes. You can see she's wobbling around, and obviously there's the tape fixing for the guys up there. We've got twisted. Some of the guys got a little twisted, but at this point it doesn't really matter. I really think we should. I really think that this shall suffice. It's a bit damp this morning. We haven't had any rain, but this. So I can feel it. It doesn't feel that wet, but it does feel damp, which is a problem. We really wouldn't want that connected on like that. But there is paint, so okay. Well, we could come back and look at these things. Let's have a look, see how it's performing. Okay, so spectrum analyzer, we've got a centre frequency of 14 megahertz. We've got a stop frequency of 28 and a start of 0. Well, it doesn't go down to 0, so oops. It's just given us this bit of anomaly here, but just ignore that. So we've got an RF bridge. It's quite straightforward. Works very similar to a SWR meter. So essentially, we've got a tracking generator sending it's basically, you can use a sweep signal generator here, or just a single generator, and then the output of this goes, it's obviously what you see in amplitude at a certain area. We've got a reference. Now this is a 50 ohm terminator, and we've got two on, because on this side, I don't think you can see that, there's another 50 ohm terminator. So if I remove that, it jumps up. So we've normalised it. So if I now plug the antenna in, it gives us these nice shapes. I'm not sure if they're nice. So to have a look at this, if that's the centre, you know, it looks like we've got, you know, that's 14 megs. But it looks like that's not going to tune up. So let's put a marker on there. Okay. And if we adjust the marker, it tells us up here. So the dip of that waveform is 1577. Now, we've got a number of things happening here. So we've got these coils in the bottom of the these tape measures, which I think I really don't like, if I'm honest. It's just because I just can't get my head around what it's going to do. So I think we should remove them. But if we look at this, you know, remember we're looking at the coax as well. So we've got characteristics of the coax, but the antenna. So we've got a well here, which is so about 4.355 megahertz. And then we've got another one here, which is about 4.5511. Yeah, they're not natural. They're not natural harmonics of the wave. And this one here is around about 15.7. Now, I've never done this before, so not with an antenna. So if we look in here, we've got about 25 megs. We seem to be resonant there as well. So obviously, yeah, the dips are the resonance areas. All this noise you can see on these are most probably shortwave radio stations. If you see that, if it's what sort of frequency. Yeah, 13 megs. Yeah, 11 megs. That's what you'd expect to see this time of day on the shortwave spectrum. Okay, so I'll cut the tapes off. You see we're connecting on as before. So we're actually, yeah, bang on. It's 5 meters exactly we've got protruding. Yeah, we'll see. And obviously, this cap is just a cap off an aerosol can. I'm not using that now. But yeah, let's see what it looks like on the analyzer now. Okay, well, it looks the same as it did before. Let's have a look. 4.3. There's our marker. Oh yeah, maybe, yeah. Okay, yeah. So it has shifted. It has shifted. So those calls didn't make a great deal of difference, and I thought they would. So 11. So that was 11.4. That's now 11.299. That's not a hell of a. Well, it has made some difference. I almost wish I'd left them on there, because then we could just literally pull the thing up and down to tune it, possibly. And what were there? 15.8. So the resonant frequency seems to have gone up, not down. So if it's gone up, not down, you think it'd be too short, but it can't be too short. Okay. Now I've got 2 elements there we're feeding. Now I don't think that's going to make much of a difference. Okay, right. I've been messing about. So I'm not too sure about this, if I'm honest. It's just an eBay special, you know. So I need to look more into it. I think it was reading right, because I checked the antenna, you know, and this is since we cut the bottom coils off the, you know, the tape measures, and it was resonant at about 11.4 megs for some reason. Now there's two radiating elements. So I've done a bit of jiggery pokery with it, and we'll do it the old fashioned way. And I've got about 20 watts there, and 175. You can, oh, that's on calibration. Is it? Oh shit. That's gone well off the charts. Hang on. Okay, it might help if you've got an antenna plugged in. Yeah, it does kind of help. Okay, so 175. So we'll do this one-handed. That's shaking too much. Okay, 1 to 1.5. You see that if it will focus? Okay, and if we go up to the top of the band, okay, that's all right. Slightly less, and if we go to the top of the band, to the bottom of the band rather. Okay, so we'll look. So about there. So, she's pretty consistent now through the band. Now I'm only throwing in 20 watts. I shouldn't really be doing that. I would be driving people mad. So yeah, I've got it tuned, but it wouldn't tune before because it was resonant at about 12 megs. Now that could well be the fact that it's got two radiating elements essentially. So I've done a bit of jiggery pokery, and while we've just got a little bit of light, I'll show you what I've done. And it was probably more luck than judgment. So yeah, just stand by. Okay, so right here I've got a roll of tape just holding things down, right, which is a bit crazy out here. So we've got the setup, we've got 4 radials, which are a total of 5 meters each. This is exactly 5 meters, the 2 tapes back to back. And what I've done, so a feeder comes off and clips onto each of those tapes where I've just taken the paint off, and now I've added this, and I thought about it. It's kind of like a gamma match kind of thingy duva, I don't know, but it seems to work really well. So let's we've got a connection here which is onto these 2 red wires which goes down to our ground. These come up, they could probably do with tidying up. And what I've done, I've got 2 of those copper plates at approximately, let me tell you, it's about 1 meter. So approximately about 1 meter. And I've got another plate, if we come around here, on the other side, which I've literally just taped on. And I put it there, I did a little bit of adjustment, and then it just came straight in. So 5 meters, and it's good across the band. It seems to be on the money. So that's the basis of the antenna. Now I'm just going to see if I can get us a couple of QSOs to make sure it's just not acting as a dummy load, which I'm sure it's not. I'm sure it will be radiating nicely. Yeah, let's see what we can. See if we can get any reports out of it. Okay, so we've got the antenna to test it. Now I've had a couple of QSOs today into Italy. I didn't record them. The Americans were coming through quite strong earlier on. But for all intents and purposes, it seems that it's getting out. And to give it a good test, I mean, well, all I can do is use the reverse beacon network. This doesn't have a keyer in it, but it does have a voice TX. I suppose you'd call it a keyer, I'm not sure. So I've recorded, and I can transmit on upper sideband, or lower sideband, doesn't matter, but I've recorded some audio of a call. So if I send this out now, we're set it at full power. I don't think it's achieving full power though, because the audio is not that loud, but we'll send it, see what we get. So have a look at the meter. Yeah, so it's not that powerful, is it? I mean, we're at on the 200 watt scale, so we're probably putting about 25 watts, I think. Okay, so if we put in onto the network, let's turn that down, put the call sign in and do a search, let's see what we get. Oh, yeah, we've got quite a bit of activity on here. So if we look on here, we've got something to the States, we're doing a lot of Europe, we've got a Sweden, we've got a bit of Finland happening there, and northern Spain. So let's have a look at the... Okay, so yeah, we've actually got some quite respectable, we've got some quite respectable signal to noise. So yeah, we get 10, 14, 16. Okay, that's into Switzerland, isn't it? Yeah, okay. Well, that's getting out. I mean, I've got no other way of testing the thing. We can do, yeah, this is the only way I can really test it. The SWR is good, so yeah, it's working. That'll do. Okay, to summarise what we've got here, I've plotted the SWR. So at this point, it's 14 megs. This is 14.35, which is the end of the 20 meter band. And down the bottom, we are, we're about at 1 to 1.6, which is pretty good. And, it gets better as we go higher up the band. So at, we're at about 12, where's that? It's about 175 is about here, isn't it? So we're at about 1 to 1.5, and then we kind of seem to stay there. So, which is good, and it's not got a sharp SWR. That's quite. I'm not that experienced with antennas, but I'd say that's pretty good. It isn't going bottoming out, but I think we'll talk about that in a second. But if we look at the other frequencies, so I've tried it on 10 megs and it's just off the charts. 18 megs, it's sort of 1 to 2.5, and then on 21 megs, it's again off the chart. So we can see where it's tuning. So if we look at the actual construction of the thing, so we've got two pieces of tape, and they're in a back-to-back configuration. There's a slight gap between them, which is about 2.5 mil. At the top here, they're joined together, which it's just the ends of the tape. Tape measures, and so it's not a very good connection, I wouldn't have thought, but that's what it is. So yeah, so the gap's 2.5, the length is 5 meters, so there's two lengths. And we've put some guide points on at 1.5 metres from the top. I know this is nowhere to scale, but hey ho. And then obviously we come down, we've got a feeder coming up here, a coax, so the centre core goes off onto each of the elements or the pieces of tape, and the braid goes to that ground plane spreader thing that we made. And then the radials come off, and they're 5 metres each, and they come off the table. I've got like a 700mm drop. I don't know what sort of effect that's going to have on the radiating angle. I've not done any modelling on this. I think you'd struggle to do modelling on this. And then the tuning, because it's behaving strangely, I've put these 2 copper plates. Now remember, these are nothing more than those little copper strips you get for labelling plants, you know, so they're about 100mm by 20mm diameter, and I've actually put a tape on to use as a dielectric, because obviously what I was looking for was some kind of capacitive effect similar to how a gamma match works. And by sliding these up and down. Now I've just literally just put these things on, and I didn't really do any adjustment, and that's what we got. And so I've left it, but I'm pretty certain we can get that SWR right down by adjusting it. But that's basically it. You know, there's not a great deal more happening. So I think long term, this wouldn't handle in the rain, but rain in the wind, in heavy winds. In fact, I know it wouldn't. But that being said, it's an emergency antenna, so it's something you can make up. Tape measures are readily available. You'll find one in just about every toolbox. I've still got. Oh, look at that. Okay, because I'll press the button. I've still got 5 metres in each of these, so we may make another one. And this time, what I may do is do it the other way round. So put them face to face, and I think that would be stronger, and just tape round the sides. I think that would make a stronger antenna, and over the length, you could pretty much. I don't know, we can find some kind of sock or something to go over it. And then you could actually roll them up, and it would take up no space at all. I mean, you could put this into a little sandwich box, the whole thing, with the element, radiators and everything. The whole lot would just fit into something very, very small. So I think that would be an advantage. Now, obviously we did the tests on it. We don't know how well it's getting out, and it's difficult to tell. And the only real way to see how this is performing is to put it next to a half-wave dipole, which I don't have. But it'd be nice just to set it up and then just see, you know, obviously carry out some tests and see how this thing's getting out. But I've had a couple of reports today I got straight into these 2 Italian stations. Come back, and they were giving us 5959 plus, and then obviously we did the test at about 25 watts, and it seemed to be, well, he was getting as far as the US, East Coast, but it was still the US. It's a good old hop. So it's performing well. You could actually make this out of something, out of what you've got lying around the house. Now, I did say I was going to use garden wire here, but I found the speaker wire. I used it. I don't know what the difference would be. Might be worth checking that. But yeah, as an emergency antenna, you had to make something. There it is. Presuming you've got a bit of coax. Tape measures are, something that you'll find. And it's a vertical, and if you haven't got a pole or anything, ideally if you want something to make an antenna, you want to string it up to a tree or something, but I haven't got a tree. So the challenge was to get something that will stand up, and we haven't got one of those DX Commander poles or whatever. They use those roach poles as well. I don't know, but You know, we haven't got that, so that's how we've done it, and I'm pretty impressed with the results. Anyway, if you like this video, please like and subscribe, and hit the notification bell if you want to see any more videos. I don't put out videos that often, but I do still enjoy making them. So anyway, we'll catch you next time. I'll possibly make another video of the other orientation to see how it goes. I think that'll be a lot stronger. So